Welcome back, guys. Good morning, all of you. In today's lecture, we'll start the unit number 5. Okay, to unit number 4, we have seen different types of the stresses, right? There is a tensile stress, compressive stress, then shear stress, and also we have seen the direct stress. Okay, in the unit number 5, we will see the principal stresses. Principal stresses. Okay, remember that when you study the principal stresses, maximum weightage is given for this unit. Okay, sometimes you will get the question on that principal stresses for 13 marks. Okay, here you have to solve the numerical of calculation, different calculation of the stresses as well as the graphical method. Means you have to solve the given numerical with help of analytical method as well as graphical method. Okay, there is a one mover circle method is given. There are three different conditions are given. With the help of that three different conditions, you have to solve the given numerical with the help of mover circle method. First, we will complete the analytical part. Before going on that analytical part, see, we know this 9 stages. Okay, first is what is meant by principal plane. Okay, this is very important. The plane on which the normal stresses is at. The plane on which normal stresses is at. There is no shear stress is at. This type of plane is called as a principal plane. Okay, the plane on which only the normal stresses is at. Normal stresses means which stresses is at. See, I have given here one example. I will give the one example. Consider a rectangular block ABCD. Okay, the stress in x direction is a sigma x tensile as well as suppose compressive stress is at, and y direction is a sigma y is at. Okay, this type of stresses is called as a normal stresses. Normal stresses. Okay, and there is a shear stress value is, shear stress is denoted by what? Tau is denoted, shear stress is denoted by tau. This value is a 0. There is a no shear stress is induced. This type of plane is called as a principal plane. Okay, remember that. Sometimes in the oral you will get the question. Okay, what is the principal plane? The plane on which only the normal stresses is at, no shear stress, is called as a principal plane. Clear? Very simple. Okay, then second is the principal stresses. What is meant by principal stresses? Yes, anybody? The magnitude of the normal stresses act on the principal plane. The magnitude of the normal stresses act on the principal plane is called as a principal stresses. Okay, means you have given some value of the principal value of the normal stresses. That value is act on the principal plane. You have to consider any one principal plane. Suppose I will consider here this one. Here is a B. I will consider this B plane. See, the value of on the B plane, C is there, E is there, and B is there. Okay, here is some value is given. Sigma x is given, suppose 70 MPa, and here is a normal stress and tangential stress is there also on that principal plane. Okay, principal plane. This is called as a principal stresses. The magnitude act on the normal plane is called as a principal stresses, or normal stresses acting on the principal plane is called as a principal stresses. Third part is a major principal stress. Okay, what is meant by major principal stress? It is denoted by sigma n1. It is denoted by the sigma n1. Remember that we want to calculate the value of major principal stress. Major means what? Maximum. It is the maximum value of a normal stress. It is the maximum value of the normal stress acting on the principal stresses is called as a major principal stress. Is called as a major principal stress. This value will get sigma n1 is equal to sigma x plus sigma y divided by 2. Okay, you have to use the trigonometry and solve this derivation. Then you will get the major as well as minor principal stress. Sigma x plus sigma y divided by 2 plus you will get root of sigma x minus sigma y divided by 2 bracket square plus tau square is there. You should remember this formula, very important when you solving the numerical on the principal stress and we want to find out the value of major principal stress, then we will require this formula. Okay, all of you getting? It is the maximum value of normal stress acting on the principal plane is called as a major principal stresses. Then what is the minor principal stresses? It is the minimum value which is act on the what? Normal stress acting on the what? Principal plane is known as a minor principal stresses. Minor principal stresses. Then it is denoted by the sigma 2, sigma n2, sigma n suffix 2 is equal to, see guys, only change is there. Here is the sign change. This will be minus. This sign here you will get the minus, and this formula you have to write as it is sigma x minus sigma y divided by 2 bracket square plus tau square. Okay, this with the help of this formula you can calculate the major principal stress. Minor principal stress. All of you getting the major principal stress and minor principal stress? It is the minimum value of the normal stress acting on the principal plane. It is the minimum value of the stress acting on the principal plane is known as a minor principal stress. And what is the major principal plane? Major principal plane again. What is the major principal plane? A plane which carries the major principal stress. A plane which carries the major principal stress. This plane is known as a major principal plane. Okay. And what is the minor principal plane? A plane which carries the minimum principal stress. Minimum principal stress. Okay. This plane is called as a minor principal plane. Minor principal plane means what is the value of the major principal plane? Major value, maximum value of the stress, and here is a minimum value of the stress. Okay, remember that major and minor principal plane. Minor means minimum, major means maximum value. Okay, then next is the resultant stress. Resultant stress. How to calculate that resultant stress? This is the resultant of normal stress and the tangential stress is known as a resultant stress. Okay, it is denoted by sigma suffix r. Sigma suffix r. And how to calculate that value sigma suffix r? If you have calculate this sigma r is equal to, you will get root of sigma n square plus sigma t square. Okay, sigma n square plus sigma t square. Okay, here I have shown this angle theta is met. I will draw again. See, in this way. Okay, here is your resultant stress sigma r, and here is sigma n normal stress, and here is sigma t tangential stress. The angle made by theta of the face, suppose here is a ABC is there, BC phase. So the resultant of normal stress and tangential stress is known as a resultant stress. Means how to calculate sigma r is equal to root of sigma n square plus sigma t square. How to calculate this? Sigma r square is equal to, again you will get the sigma n square plus sigma t square. If you have taken the square of the both side, okay, then you will get here square root, right? Resultant stress. Then next is a angle of obliquity. Angle of obliquity. Getting this formula is same. Resultant stress and angle of obliquity is same for the all, because this is the common. Sigma n is the normal stress for common or that three condition, as well as sigma t is common for the all, that three conditions. Then angle of obliquity. Angle of obliquity is denoted by phi. See, here is an angle is a phi. If you have calculated that angle phi, check that here is a sigma n is there, normal sigma t is there, and sigma r is there. Then how to calculate that? Tan phi is equal to what? You know that tan theta is equal to, right? Tan phi is equal to what? This opposite side sigma t divided by this adjacent side sigma n. Here guys, remember that if you have solved the derivation, this derivation you can solve with the help of trigonometry. You know the sin theta value, you know the cos theta value, you know the tan theta value. What is the tan phi? Tan phi is equal to opposite side divided by adjacent side. Then you will get here phi is equal to what? Phi is equal to what? Tan inverse into sigma t divided by sigma n is there. This whole formula is required to solve the numericals for the different conditions. Okay, all of you getting? First you have to remember the definitions. Principal plane. This shear stress value is always 0 in the principal plane. Principal stress, if you have magnitude of that principal stresses acting on the normal plane, then you will get the principal stresses. Then major principal stress, maximum principal stress value acting on the principal plane. Okay, then you will get the maximum principal stress, this sigma n value. You should remember this formula, sigma x plus sigma y divided by 2 plus root of sigma x minus sigma y divided by 2 bracket square plus tau square. And when you calculate the minor principal stress, then this sign only will change. Here you will get this plus is replaced by the minus. Then major principal plane, it carries the maximum value of the stress. Minor principal plane, it carries the minimum value of the stress. Then resultant stress, resultant of the which two value? Sigma n and sigma t. Means sigma n means what? Normal stress. Remember that, huh? Where sigma n is normal stress and sigma t is the tangential stress. It is denoted by the sigma t. What is the unit of the stress? Newton per mm square or Newton per meter square. Remember that. Then what is the angle of obliquity? Is the ratio of tangential stress to the normal stress, or we can say the opposite side divided by the which side? This adjacent side. Then last is a more important. This is the sign conventions part. Okay, all of you getting this basic thing? You should remember the formula. Otherwise, you can't calculate the values. Okay, that's why you should remember the formulas. Formulas are very important. Here is a sign convention for stresses. Sign convention for stresses. Check that. I will draw here some sign conventions. Check that. We have seen already. There is x direction, sigma x is that. I have considered one rectangular block. Okay. Then second, in y direction again. Here is a tensile force is at sigma y, and this one I will draw for the shear stress. Okay, if the shear stress is at upward direction and right side downward direction, then we can say this is going clockwise direction, positive direction. Okay, similar way opposite to this, here which force is at compressive force is that sigma x again. Here is a sigma y is that, and last these sign conventions also will change. This is downward left side and right side upward, then this will moving. The movement of this is negative. This movement of this negative. Okay. Then we can say this is the positive, this is the positive. Okay, because which force is that? Tensile force is that. Then we will consider the positive tension in the x and y, sigma x and sigma y. Here is a compressive force is that. Okay, push force is that. Then here I will write negative means what? Compression is there. Right? Negative. You should consider the negative value. If there is a tension, then you have to consider the positive value. If there is a compression, then you have to consider the negative value. Then here is a, I will consider if the force is at the upward direction left side and right side downward direction, then movement of this shear is clockwise. Then I will consider this is the positive shear stress. Right? This sign convention is very important. If the left side the downward force is at and right side upward force is at, upward direction force is at, then this movement of this shear stress is anti-clockwise direction, or we can say the counter-clockwise direction. Then negative, you will get the negative shear stress. Okay, clear? All of you getting the sign conventions? This is very important. When you are solving the numerical, then check this shear stress sign convention, positive or negative. Okay, you should use the sign. Okay, if this is the compressive, then you have to use the negative sign. If the positive is given, then you have to use the positive sign. Similar way for the shear stress check that this is upward direction and this is downward direction, then use the clockwise movement. Clockwise means positive shear stress. If this is given downward and this is given upward direction, then this movement of this, you will get the counterclockwise or anti-clockwise direction. Then you should consider the negative shear stress. Okay, all of you getting? This is the theory part. There are again 3 derivations are given for the different condition. We will see in the next lecture. That derivation I will not solve. I will explain how to get that answer. We want to calculate the normal stress. We want to calculate the tangential stress, then resultant stress and angle of obliquity. Also we want to calculate the major and minor stress. Okay, today we'll stop here.